By comparing trials A and B, you see that in trial A the temperature is greater, but the pressure is lower than in trial B. 11. If temperature or pressure is not constant, are your statements in 9B and 9C correct? Well, if you compare trial C and D, you see that the volume is greater for trial C, but the pressure is higher. Also, in trial C, the temperature is greater, but the volume is lower than in trial B. Number 12. Would the equations you discovered still be true if the temperature was measured in degrees? Well, you see that it wouldn't be, because when you convert from Kelvin to Celsius, Celsius to Kelvin, this is the equation. And then if you used Celsius instead, the equation would just not work. 13. If you just look at the three equations and you try plugging in values from the data table, you see that A is correct, because if you multiply each trial's pressure and volume and divide by the temperature, you get the same answer. And by getting the same answer, that means that pressure times volume divided by temperature is a constant, because no matter what, you get 1.18. Number 14. Trying to verify that PV over T equals PV over T. If you plug in values from the data table, you get the same answer, 1.18. Number 15. What needs to remain constant in order for the equation to be true? From the information section, you see this, that the variable that was not changed was the amount of gas present. The number of moles of gas always remained the same. So from that, you could see that the number of moles of gas in the container must be the same. If the moles changes, you probably wouldn't get the PV over T to equal the 1.18. If temperature remains constant, T2 would equal T1. So it wouldn't matter if the temperature is constant, the equation would become Boyle's law, because if you multiply both sides by T, you get PV equals PV. The same concept applies for the combined gas law becoming Charles's law, because if P equals P, dividing both sides by P would give you V over T equals V over T. For 18, you see that you just use the equation P1 V1 equals P2 V2, and by plugging in the values they give you, the 4.0 and the 8.0 liters, and the initial pressure of 120 kilopascals, you know that the final temperature would be 60. For B, you use the equation V1 over T1 equals V2 over T2. You just plug in the 250 and the 500 as your temperatures, and the volume being 12.0 liters, and you would get 6.0 liters. For C, you use the equation P1 V1 over T1 equals, that should say P2 V2 over T2. And by plugging in the given values in the question, you get 522.9 kilopascals. If you increase the volume by a factor of 2, or doubling the volume, that would mean that the pressure would decrease by a factor of 2. Now for some skills practice with the gas laws. Number 1, all you're doing is converting Celsius to Kelvin, and then part B is Kelvin to Celsius. And you know the equation is K equals the degrees Celsius value plus 273. So for A, you just add 39 and 273, you get 312 Kelvin. And for B, you would subtract 273 from 127, and you get negative 146 Celsius. 2. Pressure is constant for 2. So you'd use the equation V1 over T1 equals V2 over T2. And you eventually get the answer 3.67 liters for the volume. 3.